Alrighty, let's begin. So today is all about drawing a DT graph. Not graphing, not like taking data and graphing, but actually, I guess a better description or a better verb might be to sketch. To sketch a DT graph from a description. So a verbal description of some kind of motion, and you have to draw the corresponding graph. Okay? Keeping in mind that movement to the right is positive and movement to the left is negative. And in both cases, these are constant velocities. Okay? Are those lines straight lines? They are. Please remember that there's a difference between a straight line and a flat line. What does a flat line represent? Not moving. Exactly, right? So please don't say that that's a straight line. That is also a straight line. Would this be a constant velocity as well, the red one? Yeah. Just constant zero, right? Yeah, exactly. Okay. So, some of you that might have had me for grade 10 might have seen the little yellow buggy moving to the right. Speeding up and slowing down. If you accelerate to the right, okay, these are time lapse with multiple exposures of this little yellow car moving to the right. What can you tell me about the distance between the yellow cars? Getting bigger, right? Because the car is speeding up. Do you guys have the car on yours? Yeah. You do. Okay. What would the graph look like for speeding up? Be curved line up? Yeah? Constant is straight. Colby says that it would be like so. Do you agree? Yeah? He's right. Would you say that the slope is increasing? Yeah, the slope is increasing because the speed of the car is also increasing. And we already know that the slope of the position time graph is the speed of the velocity. Okay, so that's good, but that's the easiest one. Slowing down to the right. So now I'm a little yellow car. You'll notice that the little yellow car, the distances between them are getting smaller. So Jen, what does the graph going to look like? Well done. Flip it back on me to figure out what opposite means. Nice job. Can you kind of make a description with your finger? I don't know, I'm putting you on the spot, but that's okay. It's definitely a step. No. You're right, it's the opposite of that. But what does the opposite of that mean? Like starting down low and curving up, Jason? Like that, you mean? Jen, what do you say? Yeah? Could it be anything else? What else could be the opposite of that? Could this be the opposite?
No. But you're not starting at 20 at 0. You're starting at 0.
Well done. You are indeed, in this case here, you are starting at 0. Positions are you're already moving, but you are moving to the right, and you're ending here. So it can't be this one because you have to start at position at 0. So you're right, Jason. And is that what you had in mind, Jen? Yeah? Good. Would you say that the slope of the black line there is getting flatter? Yes. Cameron, would you say that? Slope is getting flatter on the black line? Right? It's getting flatter, right? And the slope, again, the slope of the position time graph is the speed. And so if the slope is getting flatter, then that means that the speed is getting slower. And if it was completely stopped, like say it remained at, what position is it at here, would you say? 14. We'll say 15 to find the car. Okay. If it stayed there for 4 seconds, what would the graph look like? Straight across, flat, right? It would stay, if it were to stay there longer. If it were there for 4, 5, 6, 7, and so on, it would stay flat like that, right? Okay, that's good. Making progress. Okay. Accelerating to the left. Now you'll notice that I made the graph here now. Before we go anywhere, let's put a little 0 right there. Because now I got to deal with negative territory. Accelerating to the left. Speeding up to the left. What are the cars, Zoe? What's the cars going to look like? Come on. Speeding up to the left. Speeding up means what about the cars? Going faster. What's the distance between the cars like when it's speeding up? Farther apart. Is that not going to be the same here? Exactly the same, just that the car is now going the other way, right? Do I have them here? You mean I got to draw them in there? Accelerating. Okay, so it's going to be like this. Go ahead. We'll put 2 there, and then we'll go. It's like little sombreros going left. Right? Wade, what's the graph going to look like? The same as the first one? So this one here, you say? But negative. Okay, what do you mean by that? Where do you want me to start? At 0 or farther up, or where? Where should I start? I guess 20 would be up here, right? Should we make that minus 20? Seems right. So you want me to start at positive 20? Yeah. And you want me to go down. Like this? Other way. Oh, hang on. I'll do a different color. You think that one? Yeah. How many people like the blue one? Nobody likes, got one. 2? How many people like the red one? Red is right. Why is the red right? Is this car speeding up? Yeah. Speeding up, how can you tell? Zoe told us that the cars are getting farther apart, right? It's speeding up, which means that the slope, if it's speeding up, that means that the slope has to be getting greater or smaller? Greater, but it's going to the left, so that greater has to be a... Go ahead, you got it right, Alana. I can tell you're going to say it. Negative, right? Negative steep. Negative steep is like this, right? That is 100% right. Negative steep like that. Who haven't I picked on? We'll go to the table of Mallory's. One of you gets to answer the first one, one of you gets to answer the second one. So whoever answers the first one, then the other person has to do the second one. What do the cars look like?
Farther apart.
Farther apart at the start, and then what?
Yeah.
And then closer together? So it'd be like farther apart, so one. Like this? Like that? You're right. Okay. Second half of the table of Mallory's. What does the graph look like? Like this one?
Yeah, but it's like, I don't know how to explain it.
Okay, yeah, it's kind of hard to explain. But like the blue one we had before? Like this to you?
Yeah.
Yes, Jason, you agree? Vinny, do you agree? He's thinking. Yeah, oh yeah? Okay, sorry. I have these big giant ears, but they don't work so good. That's absolutely right. How can you tell? Is it slowing down? So quiet today. It's slowing down, the cars are getting close together, and slowing down means that the speed is getting smaller, and the slope is the slope of the position time graph is the speed, and so if it's slowing down, the slope has to be getting closer to 0, which means flatter. Is it getting flatter now? The slope? It is, so that is correct. Okay, here's the fun part. Give me a second to set it up. Talk amongst yourselves. What I have here is a motion sensor, a little cart, Kenny. Here's the motion sensor here. What it does is, you guys know what sonar stands for? What kind of animal uses sonar? Bats, you're right. Dolphins? The subs use sonar. The sonar stands for sound navigation and ranging. So basically, it's a sound wave that goes out. Okay, it's going to shoot a sound wave out of Jason. It's going to bounce off and come back, and it's going to tell me how far away Jason is. It's going to do that like every 100th of a second. Okay, so if you're really quiet, you can hear. I'll just get this thing started up here. Okay, I'm going to do a position diagraph. So just listen. Can you hear that? A little click. So it's every one of those clicks. It's sending out a sound wave to here. It's bouncing back, and it knows the speed of sound, 330 meters per second. And based on that and the time it takes to come back to here, it can figure out how far away it is. And when I move the cart farther away, it's going to do what? It's going to be a graph farther away. Now, what if I start moving the cart back and forth? Now, it's going to make me a graph up there. Okay? And I can zoom in a bit. Oh, that's not what I wanted. There we go. Okay? So as I move back and forth, I can make my little graph of my my motion. Okay? So here's what we're going to do. Okay? So it says here, the motion detector will create a DT graph based on the motion of the cart. A wave from the motion detector is always positive. So as I move to your right, it's positive. Right? Where is 0 in real life here? Right here. Where is negative? Behind it, can we get there? No, because like obviously it's not going to work, right? So all of the graph is going to be restricted to the positive. Okay? So it says for each description, determine what the DT graph looks like. So the first one is the cart moves to the right and then immediately to the left. Okay? So you'll notice that I have for 3 of them. Is there 3? Am I right? There's 3?
Yeah.
Okay. So here we go. Under guess, I just want you to draw a graph like so. And then I want you to guess what the motion's going to look like, and then I'll actually do it. Okay, so you go ahead and guess. I'm going to do my... So the first one is the cart moves to the right and then immediately to the left. So it's going to go, I'll start it like about there. It's going to go right, and then real quick it's going to go back, right? That's what I'm going to do. Now, what happened there? Yeah, I'm not happy with that. You know why? Well, first of all, what's happening right here? Yeah, because I had to click the button and then I'm slow and I had to take me time to get over here. That took me, it looks like, almost a second and a half to get over there. Holy, that was slow. And then I moved really quick to, is this really quick to the right? How can you tell it's really quick? Steep, right? And then what happened here? It stopped. It was like, did I actually do that? It didn't feel like I did that. Did I actually do that and pause? And then come back? I'm going to do it a little bit differently here. I've got a little, perfect. This thing here, this bumper, is magnetic. Okay, so when I go like this, it's going to bounce off. Okay, let's try it out. Oh, you know what it is? It's running out of, oh, I see. I've got it switched to the short distance. Let me try that. Thought I had to set up right. There we go. Is that what you expected? Yes? Why is it peaked like that? Because there was no slowing down, right? Like if it was just my hand, if I did this, I have to turn it around. I have to slow down before I can come back, right? But because there's a bumper there, cart doesn't know. It's just trot along at a nice constant speed and boom, bounces up, right? So yeah, you should have drawn. Now, are you going to erase what you drew? Don't erase what you drew. You're going to go, and it didn't start right at 0, did it? So you're going to go like that, right? Okay. Car moves slowly left, stops, then slowly right. I get up my bumper a little later. You want to change your mind now? Slowly left, that's this way. We're going to start it here. Slow left, stop, slow ride. That's kind of boring. Jason, you want to come do it? Because then I can do the clicking thing. You want to do that? And then you want to volunteer? I kind of called in. Sorry, man. You don't have to walk slow. You know what you're doing? No, wrong way. Hang on. You're going left? What is it?
Stop.
Yeah, right. Okay, when you hear the clicks, go. Slow. Stop. There we go. Is that good? Is that kind of what you drew? Pretty close? You do have to remember, to go left, you're going to have to be to the right. Right? So it's like this, and then it slows down, it stops, and then it goes slowly to the right. Okay, left. Who wants to come? Come on up. Need a volunteer. Go on, everyone, all at once now. Come on. Zoe, come on. Come on. Sure you played with cards when you were young, no? No? Do you want to do it from that side so you don't get your left-right mixed up, or can you do it from this side? Okay. Well, yeah, because to the right is now left. So you're going left, which is... Okay. Pause. Left again. Stop. Then fast right. Can you do that? You want to practice? Okay. Left. Pause. Left. Stop. Right. It says stop. Got it?
Wait, I forgot to stop. I did it.
I think you stopped paused.
What am I supposed to do when I pause then?
Well, pause is like a short stop.
That was right.
Eh? That was right?
You just flipped your words.
What are you talking about? I said, you're telling me that a pause is longer than a stop?
You should go to the store and stop and pause.
Do the red signs at the corner say pause?
Okay, good.
Only
I'm
in...
sure people would pause.
That's called a country stop, where I'm from.
Pretty sure they wouldn't just tell the right. Oh, pause. What? Okay.
Let's have a vote.
Let's go about.
Yeah?
Let's go about.
Like, who's right here? He says a pause and a stop.
A pause is quicker.
Do it right now, so.
When you pause the game and stop the game. Yeah, it's the same.
Oh, yeah, that's good. Yeah, you can go back now. Sorry for embarrassing you.
Actually, pause.
Is that good? That's pretty good, eh? So that's going to be... It's going to be like this. Pause is just sort of like a little, and then back down again, and then stop, and then quickly right. Oh, quickly right. So that should be steeper, right? Are you getting the hang of things here? Yeah? Okay, so now you have, I think, 3 graphs, am I right? Now you have 3 graphs. Now you need to tell me what the motion is. Just in words.
Left.
3 graphs, tell me what the motion is. Okay, so it sounds like you guys are ready here. So the first one here. How do I make this graph? Left, stop, left? So I got to start, what you're saying is I got to start way out here then, right? Okay. If I have another volunteer, am I doing this myself? Left, stop. Left. Is that close? Pretty close, right? Okay, so it would be, again, left, stop, left. These are all easy ones, by the way. They're going to get a little harder. What about this one? Right, stop, left. What about the speed? Is there a speed difference here?
Yeah.
So right,
Left,
right, fast, stop, slow left. Is that what you're saying? Okay, so right, fast, stop, slow left. Right, fast, stop, slow left. Is that kind of what the picture was? Yep. Close enough, okay. And then the last one here. Oh, there's a couple of different things going on here, right?
celery.
Slowly right. Is it speeding up the whole time, or is it like two different speeds? Can you guys put the phones away, please? Guys are getting into really, really bad habits. Things are going to get a whole lot harder real quick. If you're not paying attention, you're going to be lost. It actually looks to me like there's two straight lines, right? So it's slowly right, speeds up to the right, stop, and then back left, I think, right? So slow right, speed up, stop, slow left. Am I right? Slow, speed up, stop, and back. Did I do it? Yeah. Pretty close. Okay. Sounds good. Okay, little practice quiz there at the end, but first of all, I'm going to go to my favorite group of three back here. We're going to rock, scissors, paper. One of you guys has to leave the room.
I'll just take the
You just take it? Okay. And one of you two guys come on up, and you're going to make a draft for him, and he has to try to do it. Don't go too far, baby. Anything you want. You make something like really hard, and he has to. I know. Why do you think I did that? Okay, hang on, yeah. So yeah, anything you want. You know. Yeah. This is always my favorite part. Whenever you hear the clicks, ready? Don't let him look. Is he looking in the window? He still wouldn't be able to do it. Oh. It's not bad. Think you can do it? Actually, that's one of the easier ones I've seen. You went easy on that. Yeah. Call him in. Call him in. Great. Call him in first time. Come on up. You got to figure out how to make that. Okay. Do you want it, it might help. You want to do it from the other side? Do it from the other side, right? That way you can see. Now, can you figure out where to start from? No?
It clearly started like somewhere here.
Okay. Can you tell from the graph where he started?
1.3.
Right. Is there like markings on the?
Oh, okay. 1.3. I don't understand what 1.3 is on here.
Well, that'd be 1.3 meters. So there's 0, half a meter.
Oh,
There's the full meter there. Right there? Okay. Now, when you do it, just so you know, like, you want to keep your, maybe just take your body and just step back a smidge. Yeah, because it will pick up parts of your body.
okay. So here,
You want to practice first?
50, 128, 170, 30, 28. Okay, yeah, I think I can do it.
Yeah? And see that little pause at the start there?
Yeah.
Yeah, like you wait there. You will too just naturally. Ready? Here it goes.
Over 60. Oh, he's way too fast. Really that.
Let's try again.
Okay. cherry
That's pretty good.
It's not bad. It's hard to do, isn't it? Yeah, to be honest, I've never had a kid do very well with it. It's pretty hard. Guess what, Vinny? You get to pick two more guys, or girls. So I'd be like, hey, the middle table here, Anna and Jen. Okay, you guys get to decide who goes out. No, here we'll do Rochester favor.
No.
Yeah, come on. You're going out now? Or you're coming up? Oh, you can miss it, didn't you? It's harder to go outside. Yes.
Yeah, I just like do whatever.
Do whatever you want. Yeah, hang on. Do you want to do it from the other side so you get the sense of?
Yeah.
Yeah. You can start wherever you want, wherever. Do literally whatever.
Okay.
Ready?
Okay, well.
I think what Carter did was hard enough.
There.
Okay, that's doable. I've seen this, like kids go up and they just go like. Okay, go call her in there. She went pretty easy on you.
Oh,
Can you figure out where she starts?
is it over here?
0.6 and 0.8. So that's between 60 and 8, right?
Oh,
So between so probably 7. Okay, so what did she do?
so she's slowly goes up. To the right,
Yeah.
down.
How far back did she go? Oh, did she go look?
Or is that over here?
Yeah.
Here, and then back upwards. And then she went over back. Okay.
Are you ready? You want to do a practice one?
I guess so.
You probably I'll give you 2 cracks at it anyways. Okay, ready?
Oh, sure.
Are you at the right spot?
No. Okay, here, and then you go to the right, and then left.
Ready? Wow, that's pretty good. That's as close as I've seen. Yeah, that's good. You pick 2 more. Oh, come on. The girls in the corner there? All right. Last one. Who's coming up? You going outside, Megan? Good for you. I should have prizes for this. I don't have any prizes. I said I should have prizes. Whenever you hear the clicks, whatever you like, right? Except not like crazy, though. No, don't do it crazy. Are you ready? Oh, that's a good one. Okay, call her there, guys. I have to say, I'm impressed that you guys haven't gone all crazy here. It is. It's so quiet today. It's just weird, isn't it? You know where to start? You sure? Okay. Yeah? Let's try that one more time. Okay, you got to start farther up at like 0.5, right? You got to start farther up, and you're going to go steeper, and then you got to come back here a little bit, right?
Yeah.
Maybe at 0.5?
That's
Good.
nice.
Yeah. Okay, ready?
Oh, I'm not good.
It's okay. It is not easy to do. Okay, I'm gonna volunteer. You go do one. I'll see if I can do it. You guys, someone pick do it. You guys know how to start it? Have you been watching? You gotta click on where it says run one here, I'll believe it. Maybe someone else come up and just click the button for her. Okay. You just click start when she's ready, and then it'll say stopping when. Okay? Do you think I can do it?
Nope.
Probably right. How about I just stand here and I don't, no? Can't just stand here? Why not?
Because I can see you.
Oh, you guys just weird.
Lock the door. There you go. Keep going.
$5 you won't get it.
Already do. Oh, $10 if I do it exact. How many people do I have to convince that it's exact? Just you. So you start about 1.65. And you have pause. You're going to go right.
Get your DJ skills ready.
So just click start?
No, not yet. I got $10 riding on this.
I feel like you do this at home.
I come to school.
Maybe you shouldn't want the paper on there.
Yeah, I know. Oh, okay.
There you go.
I get two cries? Two cries?
Yeah.
Only one?
I get two.
$5 if I do it on the second one. Not bargain. Okay, right?
Yeah. Oh.
Oh. That's pretty close. No? I didn't get the zigs in there. I got off track a little bit, literally.
How do I delete it?
Hang on, I want to practice more time.
Just don't hurt yourself.
Oh.
Just look.
Yeah, how did you must have been really fast at the start.
No, there's an indent in there. Just put my fingers in there.
No, I meant like at the start when you did that.
Yeah,
You just put a finger wave.
I just put my fingers in there and just.
Oh, really? Is that all you did?
Yeah.
Ah, gotcha. I'm too old for that. Okay, here. I'm gonna go. See, I did pretty good there, but I didn't come back fast enough, right?
Oh, you're like the same velocity as her.
Yeah. It's actually pretty close. I have it. Okay.
That's not too bad. Hey, how do I delete it?
Hang on. Let me go my start spot. Okay.
What magic button do I do to delete?
Oh, yeah, the actual delete button on the keyboard.
Ready?
Yeah.
Pretty good.
It's not bad.
It's hard to look up there and down there at the same
It's
time.
not $5, but
No, it's not worth $5. It's worth it. Alrighty. Fun's over. Okay, so you got a few minutes left. Here's what I want you to do. There are 5 descriptions now. They get a little bit more challenging. Okay, they're more like real world kind of thing. Okay, so there's 5 of them. I realize there's not a ton of room there. If you want to do one of those, you can. Okay, so do those 5. Then I'm going to check them, and then I'm going to leave you with A and B kind of thing for homework. Okay, so I'll give you like about, I'm going to say 6 minutes for those first 5. We should give Mr. Burnett to try one, eh?
Yeah.
Well, you got to match it.
Match what?
The movement. You got to match the graph.
So it does come close.
See? That was me. I had $5 on the line there. I didn't pay up.
So I'm looking at the library.
Yeah.
Is that the schedule request?
I have no idea. We'll go through these and then I'll be quiet for the rest of the day. A ball is thrown into the air. It lands on the ground at your feet. Do I have my... Jagger, can you grab mine? I don't want to go all the way around. Thanks, man. Out! Okay, so I got my foam ball. I'm going to throw it in the air. It lands on your ground 10 seconds later. So obviously I have to throw it really high, but we won't do it to scale, right? So I'm going to throw it up like this, and it's going to land at my feet. Okay, so notice that I started here, right? It goes up, it comes down. The whole thing takes 10 seconds. Position is measured vertically. In other words, we're interested about not the distance this way, we're interested in the distance up and down. So as it goes up, is it all going to be positive? Because 0 would be the ground, the floor. That would be the frame of reference. So I would have to start like about there, right? And I would throw it up. And as it goes up, does it keep going at the same speed? Would it be a straight line?
Yeah.
As it's going up, doesn't it slow down? Slows down, right?
How's it at the top?
What do you mean? You're right. But remember, it also shows time, right? So if the whole thing takes 10 seconds, then I have to end up like there, right? So it's going to go up into the air, and it's going to slow down, and then it's going to come back down at 10. Is that what you had? Something like that? Close? Don't erase what you had. Put the right answer. Don't erase. You can learn something from your mistake. Why is it curved? Because it's speeding up, slowing down on the way up, and it's slowing down on the way up and speeding up on the way, going faster on the way down. Okay, now question 2, I admit, is a trick question. What if the position was measured in the above example horizontally? In other words, instead of measuring the height, I'm only measuring the sideways distance. It doesn't go anywhere, does it? So what does it do? Mallory's got it. It's just at the same spot the whole time. It's flat. Because you're measuring the left, right. And all you're doing is throwing it straight up and coming right back down. Trick question. Okay. Number 3. I always get arguments here as well. A man walks for 8 minutes south from his home on Main Street, north of the Royal Bank. So those of you that are unfamiliar with Dauphin might have a little tough time here. So Main Street north, well, he's walking south, so he lives like up by the courthouse. You know where that is? Okay, and he's walking south on Main Street to the Royal Bank. South is considered negative. Now, what are you going to have as 0? Alexis, what did you put as 0 for your frame of reference? Did you put where you started, or did you put the Royal Bank as 0? Where you started. Okay. So it would be like this then, right? So what did yours look like? Okay. If a man's walking for 8 minutes, are they going to be speeding up or slowing down? Probably at a pretty constant pace. So probably a straight line, right? So it would be like walking negative, straight line like that. Then what? 2 minutes at the ATM.
How long is it taking to get home?
Doesn't say. Would you assume the same speed? If it doesn't say, you could probably assume the same speed. And he would end up back there at 0, right? Is that what you had, Alexis?
Yeah.
Something like that? Right. Does that happen often on Main Street? I gotta get out more, I guess. Or not, I suppose. Okay. Who's been to the bowling alley? Ball spends 8 minutes in the, oh, now actually, no one argued, because a lot of people said, well, what if you put the bank at 0? It would be exactly the same shape. You're right, Jason, it would just be like this, right? Exactly the same shape, just higher. But if the bowling ball spends 8 minutes in the rack waiting to be thrown, it takes 4 seconds for the ball to reach the pins, then 20 seconds to return to the rack. So again, you have to decide, where's 0? It's usually where you start. People just naturally put 0 there, right? So 8 minutes in the rack, what's it doing? Just sitting there, staying at 0 for like 8 minutes. And then 4 seconds to reach the pins. Is that positive? So like that? Slight little angle, and then 20 seconds to come back. And then hang out again, right? Something like that?
What if that was 20 seconds really more?
Probably, yeah. I mean, the scale would be, yeah. As long, if I was marking that, all I would look for to see is that this angle is less than that one. Steepness. Okay, girl leaves her locker by the office, goes to the gym. She walks 15 meters before she realizes she forgot her gym clothes. Returns to the locker, gets the clothes, proceeds to the gym. 0 locker, is that what you said? And is the gym positive direction or negative? Probably. If you have to, just make it positive, it's easier. So walking to the gym is going to be constant speed, then what? Turns around? What would it look like? Yeah, would it be like curved or would it be like a peak? She would have to slow down, right? So it would be like a slight little curve, then back to the locker, probably at a faster pace because now she's late. Then what? Wouldn't there be like a pause there?
A little.
Not a stop though, just a pause. And then really fast back to the gym. And how far up would I go?
Higher up.
Higher up? Why higher up? It's got to go past where she originally was. Yeah? What's that? Right. Okay, is that good? All right. You got 5 minutes left there. There's a few questions at the back that you can do as the homework, please. Those are the kind of questions you'll see at least one on the test.